Okay, so we're going to take up the limiting reactant question based on what Mr. Causey did. Okay, and we like him because he knows what he's talking about. Okay, so he said first we have to get our balanced chemical equation. So we have aluminum plus CuCl2, that's copper 2 chloride. And what's that going to give us? What are our products going to be from this reaction? We've done this in class, if you remember. I gave you the tin foil, we put it in the blue stuff and it went all black. And you're like, oh my God, and then the color change was less blue. Do you remember that? Yeah? Pure copper, that's right. So that formula is Cu. And, right, now what kind of reaction is this? Woo! Okay, see, remember that. Great, not balanced. So what's our ratios? What's our balanced ratios? 2, 3, 3, 2, right? Yeah. Now, I take it up a notch and do a little bit different than Mr. Causey because I want to, actually write out my ratios like this, okay? And I go a little bit further than him. Not that I'm better, just, well, maybe, who knows. How many grams? If I had 2 moles, so I'm just pretending ideally, then I would have 53 point what? What? 96, yeah. Okay. And then here I'd have 403.35, very good. And then here I would have
266.67.
like it. Okay, and here I would have
190.64.
Okay, cool. All right, so Mr. Causey said, okay, we have to look at what we actually have. Now, I said you had 10.00 grams of this and 10.00 grams of that. Which one's going to run out first? Well, wisely, and we're going to follow Mr. Causey's method, we're going to actually find out what this is. Now, if I want to go from here to here, what do I need to use? Magic square or magic triangle? Right, okay? And same thing for here. So we're going to actually figure out our moles, and then we're going to get our molar ratios, and we'll line them up against a product and see who wins, okay, and who loses. Depends on who you think the winner is and loser is. Now the magic triangle. Okay, so if I want to figure out my N of aluminum, using my magic triangle, that's the mass of aluminum divided by the molar mass of aluminum. And so that's going to be equal to 10.00 grams divided by 26.98154 grams per mole. Okay, and one thing I liked when he plugged and chugged, cross out your units, and we're left with moles, and what do we get? 0. Anyone? Bueller? 10. Divided by 26.98154 equals 0.3706. Okay, so that goes up here. So this is what we actually have. Okay, this is not necessarily what will completely react because it depends on the other reactant. Okay, so now we want to look at copper 2 chloride. .00 grams divided by, okay, now I'm going to get my molar mass here. So I'm going to go chloride is 35.4527 times 2 plus copper, 63.546 equals 134.4514. Okay, so we're going to go 134.4514 grams per mole. Cancel, cancel. .0744. Okay, so that goes up here. Okay, now let's see what Mr. Causey did. He asked to determine which one of these is the limiting reactant, which one's going to run out first. So what he did was he said, well, if I made a certain products. So which product do we want to deal with, copper or aluminum chloride? It doesn't matter. Pick one. Okay, so the question is this. How much copper would we get if we made it out of that versus how much copper would we get if we made it out of that? Whichever one of these is smaller will tell us which reactant is limiting. Okay? Which means the other one is in excess. Okay? So that's what we're going to do. So now we have to set up our magic square. But it's based on those combinations. Okay? So, and we can use our moles for this. All right? So N of copper, that's the number of coppers that we're going to produce, based on aluminum equals, and then we use our ideal up here, Cu. Okay? So our number of moles of copper ideally is what? 3, right? To 2 moles here. And this is what we're trying to find. If we were using aluminum, that 10 grams of aluminum up, how many moles would we get out the other end of copper? Okay? And so 0.3706 moles. Okay? Cancel, cancel. Okay, so I'm going to take that number. And if you think about it, just multiply it by 1.5. 0.3706 times 3 equals that, divided by 2 is 0.5559 moles. Okay. Now, if we were trying to find copper based on our copper 2 chloride going into the system, let's find out what would happen there. Okay, so it's kind of a combination of Mr. Kazi and Mr. Shramick. Mr. Shrami. Okay, that works. Don't call me that. Okay, 0.0744 moles. And again, of course, that 3:2 ratio stays the same. So 0.0744 times 3 divided by 2 . Okay. So what have we learned? Which one is the limiting reactant? What's that? Yeah. Okay. It's the limiting reactant. Now, we're going to go from there. Now, here's the rule, and it's very important. All future calculations have to be based on copper 2 chloride. Not aluminum chloride. Sorry, not aluminum. We've got more than enough aluminum. Now the cool thing is that means that we're going to actually have lots of aluminum left over. Okay? So of this 10 grams, okay, that's going to be all used up. Okay? This is going to have some left over. Some of it's going to be used. Some of it's going to be left over. Okay? Does that make sense? Kind of like if you're driving in your car, you've got gasoline as one of the reactants. And what's the other reactant? that causes your car to go? Oxygen. Where do we get our oxygen from? The air, right? You think of the car air intakes, right? How many have ever heard of fuel injection, right? So that's a little mechanism in your car that puts more gasoline in, but we also have to have a certain proportion of oxygen being sucked in. Which one do we run out of first, gasoline or oxygen? Thank God, yes, we haven't run out of oxygen yet, okay? Thanks to the circle of life, photosynthesis, right? But we're kind of heading in that direction. We should make some changes, yeah? Okay, cool. So, all of our calculations then must be based on CuCl2, not on aluminum chloride, because CuCl2 is the limiting reactant, and that's how you do that, okay? So you take each reactant, you figure out who's going to make more, and whoever makes more, they're not the limiting reactant. The one that makes less is the limiting reactant, okay? Okay, so that one's the limiting reactant. This one's going to be excess. Whoops. Here. Okay. So we got to use all of our calculations based on CuCl3. Okay? That's the deal. Everyone cool? So here's my question to you, and this will be your homework, and we'll take it up. Question number 1, and I'll put this on the blog, this video, okay? Number 1, how much aluminum in grams was A, used, B, left over, okay? And question 2, how many grams of copper is actually produced? Okay, we'll take these questions up tomorrow, but it's for homework, and we will go from there. All right? And we'll take that video and put that video up tomorrow.